Hi, today we're looking at Functional Skills Maths Level 2. We've got the PearsonEdexcel exam board. This is sample paper 1 and we're going to start with the non-calculator section. Question 1. Ria works in a paint shop. She needs to make 1,500 millilitres of purple paint. Ria makes purple paint by mixing red paint and blue paint and white paint in the ratio 3:2:1. How much blue paint does Ria need to make 1,500 millilitres of purple paint? Okay, so we're going to try and turn all of these words into some numbers and little pictures so we don't have to have so much to read and work out. So let's start with this ratio here. We've got a ratio of red paint to blue paint to white paint. So we can do a quick little ratio table. And we're going to have red, blue, white, and we'll have a total column. And the ratio is 3 red to 2 blue and 1 white. So every time we've got 3 amounts of red, we need 2 for blue and 1 for white. If that's all we had, then 3 plus 2 plus 1 would be a total of 6. But in fact, what we want is a total of 1,500 millilitres of paint. So we want to know how many times bigger is this than this, and then we can fill in our values for red, blue and white. So the way we're going to work that out is by saying, well, let's do 1,500 divided by 6. So if we do this using the bust-up method, we say, well, does 6 go into 1? No. What about 6 into 15? We've got 6, 12, that's twice, and then 13, 14, 15, it's remainder 3. So how many times does 6 go into 30? 6, 12, 18, 24, 30. That's 5 times, and 6 goes into 0, 0 times. So this is 250 times bigger. So it means we need to multiply all of these values by 250. But we're only interested in blue paint. That's what they're asking us to work out. So we only really need to do that one. So we want to multiply the 2 by 250. So 2 times 0 is 0. 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5. So we're going to need 500 millilitres of blue paint, and we can write that in our answer box down here. Question 2. Here is some information about the number of houses sold by 20 salespeople. So 7 of the salespeople sold between 1 and 5 houses, 6 of them sold between 6 and 10 houses, 5 of them sold between 11 and 15, and 2 of them sold between 16 and 20. Right, so they're asking us to work out an estimate for the mean number of houses sold. Okay, so if you just took your average salesperson, how many houses would they sell? Now, the estimate bit, the reason that they're using this word is because we don't know exactly how many each salesperson sold. We just know that it's within each of these ranges. So what we're going to need to do is say, well, let's go with the midpoint of each of these ranges. So we don't know if they sold 1 house, 5 houses, somewhere in the middle. So we'll go, what's right in the middle of 1 and 5? And the way we can do that is by adding the 1 and the 5 together to give us 6, divide it by 2 to give us 3. Otherwise, you could think, well, if I've got 1, 2, 3, 4, 5, what number would be in the middle? Would be the 3. We do it the same for all of these ranges. So 6 plus 10 is 16. 16 divided by 2, 2, 4, 6, 8, 10, 12, 14, 16, that's 8. 11 and 15, we get 26, and then divide 26 by 2. 2 goes into 2 once, 2 into 6, 2, 4, 6, 3 times. So the midpoint, halfway between them, is 13, and 16 and 20, we get a total of 36. We want right in the middle, so we're going to divide that 36 by 2. 2 goes into 3 once, remainder 1, and 2 goes into 16, 2, 4, 6, 8, 10, 12, 14, 16, 8 times. Okay, so now we've got our midpoints. This is the estimating bit. So we don't need these ranges anymore. So what we're saying with these is that there were 7 salesmen that sold 3 houses, 6 that sold 8, 5 that sold 13, and so on. When we're trying to work out the mean, we need to work out the total and divide it by the frequency. Now it's good to think about what this total is. And this is going to be the total number of houses sold. So if we want to know the total number, well, if there were 3 salesmen that sold 7 houses each, we want 3 times 7, or 7 times 3. So 3 times 7, we get 7, 14, 21. So there are a total of 21 houses sold for these. We do the same for each. So 6 times 8, 8, 16, 24, 32, 40, 48. 5 times 13, well, we can do that one with a column. 3 5s, 5, 10, 15. Carry the 1, and 1 times 5 is 5, plus a 1 is 6. And 2 lots of 18. 2 times 8 is 16. 1 times 2 is 2, plus 1 is 3. So these are the number of houses sold for each of these. We want the total altogether. So 1 plus 8 is 9, plus 5 is 14, plus 6 is 20. 2 plus 4 is 6, plus 6 is 12, plus 3 is 15, plus 2 is 17. So there are a total of 170 houses sold. And the frequency, well, that's the number of salespeople. We can add it up here. So 7 plus 6 is 13, plus 5 is 18, plus 2 is 20. But actually they told us that anyway. Okay, so we need to work this out. Well, we can cancel the zeros. So we've got 17 divided by 2. Let's use the bus stop method. 2 doesn't go into 1. What about 2 into 17? 2, 4, 6, 8, 10, 12, 14, 16. So that's 8 times. But we've got 1 left over. So we can put 0.0. So we've got somewhere to carry the 1. We need a decimal point here. How many times does 2 go into 10? 2, 4, 6, 8, 10. 5. So our estimate for the mean is 8.5. And we can put that in our answer box. Question 3. Amanda wants to buy a new mobile phone. She sees these 2 offers for the same mobile phone. Offer A, 2-year contract, monthly cost £59 and mobile phone cost £39.96. And offer B, SIM-only plan with monthly cost of £11 and a mobile phone cost of £889.92. Amanda says, I will save more than £300 in total over 2 years with offer B. So she's saying this one's cheaper. Use estimation to check if her statement is reasonable. You must show your working. Okay, so let's start with offer A. Now, they want us to estimate, well, if it's a 2-year contract, we've got 12 months in a year, So 2 times 12, 2 2s are 4, 1 times 2 is 2. So we've got 24 months. And the monthly cost is £59. Well, because we're estimating, we can say £59 is approximately equal to £60. So what we want is we want 24 times 60. I'm going to ignore the 0 for now and do 4 times 6. So we've got 6, 12, 18, 24. 2 times 6 is 12, plus the 2 is 14. Now, 6 times 24 is 144, but we wanted 60, so we can just put a 0 on the end. So we're going to have £1,440. We've also got the mobile phone cost, or £39.96. We can say that's approximately equal to £40. So if we add the 40 on here, 0 plus 0 is 0, 4 plus 4 is 8, 4 and nothing is 4, 1 and nothing is 1. So we get a total cost of £1,480. Now let's look at offer B. So with this one, monthly cost is £11, but because we're estimating, let's say, well, that's approximately equal to £10. Now, we know that we've got 24 months, because we worked that out over here. So we want 24 times 10. Well, if you multiply by 10, you just put a 0 on the end. So that's going to be our cost there. We've got to add on the mobile phone cost as well. Well, this is approximately equal to £900. You could round it to 890, but we're going to make it nice and simple. So £900. So if we add this on, 0 plus 0 is 0, 4 plus 0 is 4, 2 plus 9 is 11. So we've got £1,140. And so she said that B would be cheaper, but she said she will save more than £300. Well, to find out how much she's saving, we'll take the more expensive one, 1,480, and subtract the cheaper one. 0 minus 0 is 0, 8 minus 4 is 4, 4 minus 1 is 3, 1 minus 1 is nothing. So we've got a saving of £340, which is more than £300. So check if her statement is reasonable. So I'll save more than 100. So we can say yes. Simple as that. We've got this figure. We're giving our answer. Okay, question 4. Matt buys a new fish tank. The fish tank is in the shape of a cuboid. The diagram shows water in the tank, so that's this dark bit down here. Matt knows 1,000 centimetres cubed equals 1 litre. 1 gallon equals 4.5 litres. He can keep 2 small fish in the tank for every 1 gallon of water in the tank. Matt thinks he can keep more than 36 small fish in the tank. Is Matt correct? Okay, so what we want to do first is work out how much we've got in here. So we're going to be working this out in centimetres cubed. We'll then want to convert that to litres, turn it into gallons, and find out how many fish we can hold so we can compare it to this number here. So the volume of the cuboid is the length times the width times the height. So the length, we've got 100, times the width, which is 30, times the height, which is also 30. Well, we can ignore the zeros for now. 1 times 3 is 3, times 3 is 9. And then just put 1, 2, 3, 4 zeros on the end. So we've got 90,000 centimetres cubed. Now to turn that into litres, we're going to need to divide it by 1,000. Or cross off 1, 2, 3 zeros for each of those. So we end up with 90 litres. Right, so we've got our 90 litres. We know that 1 gallon is 4.5 litres. So we want to divide this by 4.5. Right, now we've got the decimal here. It might help if we write this as 90 over 4.5. Now, obviously, we wouldn't normally have a decimal in a fraction like this. So what we can do is if we multiply top and bottom by 10, or in other words, move our decimal point over, we can say it's the same as 900 divided by 45. Now, if we were doing that with the bus stop method, we'd say, well, how many times does 45 go into 9 or 0? What about 45 into 90? Well, let's see. What about if we had two 45s? What would that give us? 5 plus 5 is 10. 4 plus 4 is 8. Plus 1 is 9. Two 45s are 90. So 45 goes into 90 twice. 45 goes into 0 times. Okay, so we've said 90 divided by 4.5 is 20. And that's going to be our gallons. Okay. Or you could recognise it from here to see that 4.5 is half of 9, which gives you 2, it goes in twice, and then add the 0. So we've got 20 gallons. He can keep 2 small fish for every 1 gallon. So we've got 20 gallons, so it's going to be 20 times 2. 2 times 0 is 0, 2 times 2 is 4. So we can have 40 fish. Matt thinks he can keep more than 36 small fish in the tank. Well, 40 is more than 36, so is Matt correct? Yes, he is. And that was for 6 marks, that one. And that's the end of the non-calculator section. Okay, so now we're going to have a look at the calculator section. Okay, question 1. Dataset A has a median value of 3.1. Here is dataset B. Okay, different values. We've got some negatives in there as well. Write a statement to compare the median values of the 2 sets of data. Well, if we're going to compare the median values, well, we need to know what the median is of this set. Now, the way I'm going to do that, the median value is the middle value, but we need to have them sorted in order for either increasing or decreasing order. So I'm going to go with the smallest first. So let's look at all the negatives. These are my negatives. So which is the most negative? What's this one here? So that would be 1. That'll be our first one. Then the next most negative is this. And this one. And this one. Now with the positive numbers, we just, what's the smallest? And that will be last. So I've ranked them all. Now I'm going to rewrite them. So number 1 is minus 38. Number 2 is minus 13. Third was minus 9. Fourth minus 2. Fifth is 14. And sixth is 28. So now we can rule out the smallest and largest. Keep going till we're left with 2 in the middle. If we had an odd number of values, we'd have just 1 in the middle. But because it's an even number, we've got 2. So we need to add them together and then divide that by 2. So minus 9 plus minus 2. Well, let's think of a number line. There's our 0. There's our minus 9. Now, if we're minus 2, so where we've got plus and minus, this becomes just minus. So minus 2 means we need to go to the left by 2 on the number line. We're getting more negative. So it'll be 1, 2, so minus 10, minus 11. Okay, so this becomes minus 11 divided by 2. So we can do that using the bus stop method. So 2 into 11, Note that I'm ignoring the negative, the minus sign for now. I'll put it back in afterwards. So 2 into 11, 2, 4, 6, 8, 10 is 5 times. Remainder 1, so we can put 0.0 and carry our 1 there. Decimal point at the top. 2 into 10, 2, 4, 6, 8, 10, 5 times. So we've got a median of 5.5, but remember it's minus. So minus 5.5. Okay. Now they wanted us to write a statement to compare the median values, so we can say the median of data set B, which is this one, is less than that of data set A. And we can put them in, so minus 5.5 versus 3.1. Now we've got a second part to this question. Show a check of your answer for the median of data set B. So what I'm going to do is the check, I'm going to work backwards. So I'm going to say, well, we had minus 5.5. Now to get to that, if you remember, we divided 11 by 2. So we're going to do it in reverse. We're going to do 5.5 times 2. I've got the decimal point in there. The way I'd normally do it would be to ignore the decimal point. So let's pretend it's not there. And we say 2 times 5 is 10. 2 times 5 is 10 again, plus the 1 is 11. But then we put our decimal point, we've got one decimal place, so we put it back in there. We've got the minus, so we're going to have minus 11. Now we're still working backwards. If you remember, we got minus 11 by adding minus 9 to minus 2. So the opposite of that is going to be if we've got minus 11 and we take away minus 2. Now when you've got minus and minus right next to each other, it becomes a plus. So minus 11 plus 2, we're going to be going, think of our number line again, minus 11 here, plus 2, we're going in this direction. So 1, 2, we'd have minus 10, minus 9. It's taken us back to what we started with. Great, that's our check. Okay, question 2. Dan throws 2 fair dice. By fair dice, it means there's the same chance of landing on each of the faces. The numbers on dice A are 1, minus 2, 3, minus 4, 5, and minus 6. So it's not a standard dice. And the numbers on dice B are minus 1, 2, minus 3, 4, minus 5, and 6. The table shows some total scores from throwing the 2 dice. Here we go. And the first part of the question is to complete the table. Right, so what we need to do for each of these, we just need to add the numbers in the opposite, or the one at the top with the one on the left. Now, we can use our calculator here. In fact, with question 1 that we just did, we could have used our calculator there as well, so we would have saved time. So what we're going to do is say we've got minus 2, or with a simple calculator you often have to put the number in and then put the minus in afterwards. So minus 2 or 2 minus plus 2, well, they should cancel each other out and give us a 0. Let's do the top row first. So we've got 5 plus, but it's plus minus 1. So we get 4. Go down here, we've done the 0 already. We've got 2 plus minus 6, or 6 minus, gives us minus 4. Here we've got minus 3 plus 3, so again they're going to cancel each other out. We've got minus 3 plus 5, gives us 2. Minus 3 plus 6 minus, gives us minus 9. We've got 4 plus 3, that should be a nice straightforward one, gives us 7. 4 plus 5, 9. 4 plus 6 minus, gives us minus 2. We've got minus 5 here. And we're adding minus 2 to give minus 7. Minus 5 and minus 4. Gives us minus 9. Now bottom row. 6 plus 1, 7. Don't need a calculator for that. 6 plus 2 minus is 4. And finally, 6 plus 5 is 11. Okay, so it's reasonably straightforward, but you can get mixed up with the negative numbers, so it's good to check those carefully. Part B, what is the probability that the total score is minus 11? Okay, well, how many scores are there? There's all of these. So we could count them up, 1, 2, 3, 4, 5, 6, 7, 8. Or we could say, well, we've got 6 this way, 6 that way. So 6 times 6, 6 times 6, 36. So 36 options. How many of them have a score of minus 11? Well, only one. So it's going to be 1 out of 36. Dan throws the 2 dice again. What is the probability that the new total score is 0? Okay, well, again, there's 36 possible outcomes. How many are 0? 1, 2, 3, 4, 5, 6. So it's going to be 6 out of 36. Question 3. Last year, Zach had 2 jobs. Zach worked in an office for 12 months and earned £2,600 per month, and at a gym for 39 weekends and earned £80 per weekend. What fraction of his total income last year came from his work at the gym? Write the fraction in its simplest form. So we want total income. So to do that, we're going to have to work out the income for each of the 2 jobs. So 12 months, and he got 2,600 a month. So let's multiply those 2 together. We get £31,200. Then he worked 39 weekends and got £80 per weekend. And got 3,120. So the total income is £34,320. They want what fraction of his total income, so that means the total income is going to be at the bottom, came from his work at the gym. The gym was this number at the top. Write the fraction in its simplest form. So if you've got a scientific calculator, you can work it out with the press of a button. Now, if we try and do this on our calculator here, we don't get a nice number. So we're going to have to do a little bit of work ourselves. We can cancel the zeros. So we've got 312 divided by 3,432. Well, they're both even, so let's divide them both by 2. So 312 divided by 2 gives us 156. And 3432 divided by 2 gives us 1,716. Now, you could try and do it quicker ways, look for bigger numbers, but they're still both even, so I'm just going to keep dividing by 2. That gives 78 on the top. And 1,716 divided by 2 gives us 858. Okay, still even. Let's divide by 2 again. Gives us 39 up here. And 858 divided by 2 gives This is 429. Okay, they're not even anymore. So what about just 3 go into them? Let's try. 39 divided by 3 gives us 13. And what about 429? Can we divide that by 13? Yeah. Oh, did I type the wrong number? 429 divided by 3, sorry. 143. Now, I don't think we can go any further than this with smaller numbers. The only number factors of 13 are 1 and 13. So the only number that might go into 143 is 13. Let's try that. Yes. So we can divide them both by 13. So 13 goes into 13 once. And we've just seen 13 goes into 143 11 times. So quite a bit of work there. But it is worth 4 marks. Okay, question 4. Here is a prism. The cross section of the prism is a pentagon. Okay, so that's this. We've got 1, 2, 3, 4, 5 sides. That's our pentagon. And they're asking us to draw the front elevation of the prism on the grid. Use the scale of 1 to 3. Okay, so they want us to draw this. This is the front here. 1 to 3. So that means 1 centimetre on the grid is going to be 3 in real life. So in other words, what we need to do is divide all of these by 3. We don't need the depth because we're only looking at the front. Okay, so let's start here. 15 divided by 3 is 5 centimetres. 10.5 divided by 3 is 3.5 centimetres. 4.5 divided by 3, 1.5 centimetres. And 18 divided by 3 equals 6 centimetres. Right, so let's go down to our grid now. We want to draw it on here. Let's have our bottom corner, say, down here. And we need to go up 5 centimetres. So 1, 2, 3, 4, 5. On there. Then we need to go across 3.5 centimetres. So 1, 2, 3.5. Now we haven't got this diagonal bit, so I'm going to ignore that for now. I'm going to go down the bottom next. We've got 6 centimetres along the bottom. So 1, 2, 3, 4, 5, 6. And then we need to go up by 1.5 centimetres here. So 1.5. And then we can close it off. So we don't need to know how long that was because we're just going to join the dots. And then we have it. Okay, question 5. Let's move it up so we can get all or as much of the question in as we can. Olga has this sketch of the paths in a park. All these different ones here and around here. She wants a cycle route that starts and ends at the entrance, goes through point C at least once, and has a total length between 15 kilometres and 20 kilometres. We're told that 1 kilometre equals 0.6 of a mile. Plan a suitable route. Work out the total distance of the route. And this is worth 5 marks. Right, well, all of our measurements on here are in miles, but we want a total length between 15 and 20 kilometres. So what we can do is we can convert these into miles. Then we can just work with one set of units. Well, if 1 kilometre is 0.6 miles, we need to multiply this by 0.6. And we get that that is 9 miles. And a check to make sure we've gone the right way, we can see a kilometre is less than a mile because it's only 0.6 of a mile. Okay, so we should have fewer miles than kilometres, which is right. Do the same with this. We're going to multiply the 20 by 0.6. And we get 12 miles. So we want our total route to be between 9 and 12 miles. So there could be more than one, well, there will be more than one right answer on this. We've got to start at the entrance. We've got to work out a route that goes through C, gets back to the entrance, and is between 9 and 12 miles. So let's see, we could try going this way. Then up to here, we've got 1 3/4 and 2 1/4. So it's going to be about 4 miles. Then we could go this way, would take us up to 8 and a bit, and then come back that way maybe. Let's see, so if we're doing that, we're going to be starting at the entrance and going to D, which is 1 3/4 miles. Then we'd be going from D to C, and that's 2 1/4 miles. Then from C to B is 4 1/4 miles. Then B to A is half a mile. A to F is 1/4 of a mile, and F back to the entrance is another 1/4 of a mile. So we can add these up. What I'm going to do is I'm going to convert them into decimals. That'll make it easier. So I know that 3/4 or 1 3/4 would be 1.75. So 2 1/4, 2.25, 4 1/4, 4.25. A half is 0.5, and 1/4 is 0.25. So let's add these together. 1.75 plus 2.25 plus 4.25 plus 0.5 plus 0.25 plus 0.25. We get 9.25 miles, which is between 9 and 12 miles. So we can stick with that. It depends how comfortable you are adding your quarters and halves when you're going round. If you are comfortable, then brilliant, you can work out your route straight away. If you're not, then I'd say, well, do one route, work out the total distance, and then see, do I need to make it further? Do I need to cut it shorter? And you can adjust it from there. But we're in the range we need to be, so we can just stop. Question 6. Here is a cube of side length 2.5 centimetres. So because it's a cube, that's going to be 2.5 as well. And that's going to be 2.5 as well. Work out the surface area of this cube. Right, surface area, so that's if we flattened this out. And if you imagine if we flattened out the cube, we'd have 4 squares going around the sides, so something like that. And then we'd have our top and bottom on here. Okay, so they might not look like exact squares, but it's just to help us visualize this. So we've got 1, 2, 3, 4, 5, 6 squares there. Surface area, so we want the area of each of them. Well, the area of one of the squares is going to be, well, let's say this one would be 2.5 by 2.5. Which gives us 6.25 centimetres squared. Well, we've got 6 of these, so let's just multiply it by 6. And we get 37.5 is area, so we've got centimetres squared. And that's what we need for 3 marks. Question 7. Megan is the manager of a computer shop. She organises a sale with 18% off all tablets. Megan changes the price of one tablet from £389 to £330.98. Has Megan changed the price correctly? Okay, well, let's work out 18%. It's 18 out of 100 of, which means times 389. This will give us the discount, and then we can take it off of the original price and see if she's right. So the discount is £70 and 2p. So we want 389 minus £70 and 2p. I'll put that in memory. 389 minus memory recall, £318.98, which is not equal to £330.98. So has Megan changed the price correctly? No, she has not. Now we've got a second part to this question. Use estimation to show a check of your answer. Well, we needed to work out 18%. I'm going to say 18% is approximately equal to 20%. And we wanted, and we can say, well, £389 is approximately equal to £400. So what we can say is, well, 10% of 400 would just be 40. Take a zero off. So 20% of 400, well, 20 is double 10. So multiply it by 2. 2 zeros are 0. 2 times 4 is 8. So we get £80. So now if we do our 400 and take off 80, 0 minus 0 is 0. 0 minus 8 we can't do, so reduce that by 1. Make that 10 minus 8 is 2. 3 minus nothing is 3. We got £320. Well, if you remember, what we calculated was 318.98. So we can say, well, 320, that's approximately equal to 318.98. So that looks good to me. It's close enough. Question 8. A team of workers deliver identical fridges. The team will use the average time to fully load an old lorry to predict the time to fully load a new lorry. The table shows the times it took to fully load the old lorry with 24 fridges. Okay, so these are the times of different lorry loads. The diagram shows the space available for fridges in the new lorry. The space is in the shape of a cuboid. Okay, let's shift it up here so we can see all the question now. Yeah. Each fridge needs a rectangular floor space, 1000 millimeters by 800 millimeters. The team do not stack fridges, so they can't go up, they can only go on the floor. They think it will take less than 90 minutes to fully load the new lorry. Are they correct? And it's a 6-mark excuse me. It's a 6-mark question. Right, so it's quite a bit to get your head around. So what are we actually being asked? Well, they've changed their lorry. They had an old lorry that you could fit 24 fridges in. We've now got a new lorry. We don't know how many fridges we can fit in that yet. We're going to have to work that out. But we can use our time. So what we can do, if we can work out the time, an average time for the old lorry, we can use that to work out how long it takes to load one fridge. We then should have the number of fridges we can fit in the new lorry, and we can use that time for one fridge and multiply it by the number of fridges in the new lorry to give us our new time. Okay, hopefully that makes sense. So let's start off by working out the mean of these loading times. So the mean is going to be the total divided by the frequency. So what's our total? Let's clear that. So we've got 52 plus 60 plus 55 plus 59 plus 54 plus 63 plus 56. So we've got a total of 399. And we had 1, 2, 3, 4, 5, 6, 7. So the mean loading time will be 57 minutes. Okay, so we had 24 fridges. So 57 divided by 24 would be 2.375 minutes per fridge. Okay. Now, this is our space. I'm going to draw a sketch. So we're only interested in the bottom. We don't care how high it is because we're not stacking them. So we've got 13,600 millimeters that way and 2,400 millimeters that way. Now, each fridge needs a rectangular floor space of 1,000 millimeters by 800 millimeters. Okay, so we've got to fit these rectangles in somehow. Depends how we want to stack them, or we could stack them that way. What I'm looking at is I'm seeing, well, we've got 24 or 2,400, but it's the 24 and the 8 that I'm looking at. I'm thinking, well, 8 goes into 24. In fact, if we check, well, 2,400 divided by 800, yeah, it goes 3 times. So what we're saying, if we forget about that, we can fit 3 fridges down this way, because we'd have 800, 800, 800. So if we draw another rectangle on this side, this is for the number of fridges, we can fit 3 fridges that way. How many fridges can we fit this way? We've got 1,600, and we know that each one is 1,000 long. So if we divide that by 1,000, we've got 13.6. But you can't have 0.6 of a fridge, so we can have 13 whole fridges. Okay, so we're gonna. This I won't draw them on because it's. Oh, right, maybe I will. It would be this sort of idea. We'd have that until we can fit them all in. So the total number of fridges in the new lorry will be 3 times 13, which is 39 fridges. We know that it takes 2.375 minutes per fridge. So if we do 39 times 2.375, this will tell us how many minutes it's going to take to load them all, which is 92.625 minutes. They think it will take less than 90. Well, no, that is more than 90. So are they correct? No. Okay, so there is a lot going on there. So you've got to work out the mean, you've got to work out how many fridges you can fit in the new lorry, and then use that to work out how long it's going to take to load the new lorry, and finally do your comparison at the end. Question 9. Louis makes a cake. The cake is in the shape of a cylinder with diameter 14 inches. I'm actually going to draw the other side of the cake there because I think it makes it easy to see the cylinder. Okay, 14 inches across. Louis needs to put a ribbon around this cake. The ribbon will go around the cake once with a 6-inch overlap. Louis has a piece of ribbon 48 inches in length. Is this piece of ribbon long enough for this cake? Well, first thing we need to do is work out what the distance around the cake is. So we want the circumference. And Hopefully you'll remember that you can work out the circumference in two ways. You can say pi d or 2 pi r, depending on if you've got the diameter or the radius. We've got the diameter, so we're going to go with this one. So pi, we can use 3.14, and I believe that they tell us that on the front of the paper. They do. So that's, if you can't remember, look on the front of the paper, they tell you it's 3.14. We multiply that by the diameter, which is 14. So we get 43.96 centimetres. Now that's the circumference, but remember we want a 6-inch, oh not centimetres, sorry, it's inches. 6-inch overlap. So we need to add 6 to this. 49.96. Inches. Louis has a piece of ribbon 48 inches in length. Well, that's more than 48. Is a piece of ribbon long enough? No, I'm afraid it's not. Going to need a longer ribbon. Question 10. The scatter diagram shows some information about 12 athletes who have run a race. We've got their age and we've got their time. Here is the information for another athlete. Age 36, time 29 minutes. Plot this information on the scatter diagram. So age 36. Well, if we look, we've got a gap of 10 years here, but we've only got 1, 2, 3, 4, 5 squares. So we must be going up in 2 each time. So that'd be 32, 34, 36 would be here. And we want 29 minutes. So I'm actually going to use my ruler. So I can go up from 36 and 29, 25, 26, 27, 28, 29. So it should be there. I think I've got that right. Yes. Part B. Draw the line of best fit on the scatter diagram. So line of best fit, there could be more than one right answer to this. You want a straight line that starts from one side of the data to the other. We don't want it to go beyond or just in the middle. It needs to be a straight line drawn with a ruler. It needs to follow the overall kind of trend of the data. And we want roughly the same number of values above it as below it. It's a bit tricky because we've got this value down here. We can treat that as a bit of an outlier, but I'm going to draw something like that. I could have maybe drawn it a bit more down to the right. That's okay. And for part C, describe the relationship shown in this scatter diagram. So you can use words to say as the age increases, the time increases, or you can just say, because one goes up, the other goes up, you can just say it is a positive correlation. The opposite would be as one goes up, the other goes down, so you'd have a line this way, that would then be a, that way would be a negative correlation. That's just for your notes, that's not for this question. Okay, question 11. George will cover part of the floor with tiles. The part of the floor is in the shape of a triangle as shown. Okay. George buys tiles in packs. Each pack covers 1 metre squared and costs £39.95. The tiles can be cut and joined. George gets 1/3 off the cost of the packs of tiles. Work out the lowest cost of the tiles for George. So we need to work out the area of this floor first of all. But if we look, the pack is measured in metres squared. We've got these in centimetres. So I'm going to turn them into metres first. Now we've got 100 centimetres in 1 metre. So I'm going to divide these by 100. So 305 divided by 100 means we've got 3.05 metres, and 371.5 divided by 100 gives us 3.715 metres. Now for this, the area of the triangle is half times the base times the height. So it's going to be half, or 0.5, times the base, which is 3.715, times the height, which is 3.05. Oh, did I press plus? Make sure I meant times. 3.715 times 3.05. And actually, if we want to do a check, we can say this is about 4, this is about 3. So 4 times 3 is 12. Half of it, our answer should be about 6. Yeah, not too bad. 5.665, blah, blah, blah. And that's going to be metres squared. Now, each pack covers 1 metre squared. Okay, so if it's 5.6, we're going to need to buy 6 packs. Okay, because we won't have enough with 5, we need to get a 6 pack, even though we don't need all of that 6 pack. Okay, 6 packs cost £39.95 each. So we can do 6 times £39.95. £239.7, because it's money, we need to make that 70. Now, George gets 1/3 off the cost of the packs of tiles. So we can work out 1/3 and take it off of this. But I'm going to do a shortcut and say, well, if it's 1/3 off, that means that what we actually do want is 2/3. So we can do 2/3 of £239.70. And we get £159.80. So if you're not comfortable doing the 2/3, take 1/3 off. So work out 1/3, take it away, and you'll see that you get the same as this. Because that's what we've done. We've taken 1/3 off, so we're left with 2/3. And finally, question 12. Gabby wants to buy a flat. The cost of the flat is £175,000. The bank uses this formula to work out the mortgage Gabby can get. So we've got, sorry, straighten that. Mortgage is 4.625A. So when you've got a number next to a letter, it means that you multiply them. M is the mortgage, A is the annual income. Gabby has an annual income of £34,000. She will have to pay a deposit for the flat. The deposit is the difference between the cost of the flat, you know what that is, and the mortgage. Work out the deposit Gabby will have to pay. So first we work out what the mortgage is. So 4.625 times the annual income, which is 34,000. 4.625 times 34,000 gives us £157,250. Right, we want the difference between the cost and the mortgage, so we want 175,000 minus 157,250. So I can put that in my memory. 175,000 minus memory recall gives £17,750. That was part A. We do have a part B as well, so we're not quite there yet. Gabby invests £4,000 for 3 years. The investment earns 2% compound interest per annum. Work out the value of the investment at the end of 3 years. So we've got £4,000, getting 2% interest per annum. We want to know what the original amount is increasing to. So if you think we're going to start with 100%, and we're going to add on 2%. So that's going to give 102%. Now, we can't multiply it by, well, we can multiply it by 102%, but that's the same as saying 102 divided by 100, which gives us 1.02. So, if we multiply it by 1.02, it's the same as saying we want 102% of 4,000. So that'll give us the value after 1 year. So after 2 years, we do the same. We want 3 years, so we're going to multiply it by another 102%. So 4,000 times 1.02 times 1.02 times 1.02, and we get 4,244.832. This is money, so we can only have 2 decimal places. We look at this digit, it's less than 5, so it's just going to be £4,244.83. And we can write that in our box down here, so we've done it all properly. 4,244.83. And there you go, you can see we finished the paper. So thanks for watching, hope you found it helpful. Please like the video, subscribe to the channel, turn on notifications so you find out when I upload more videos, and I look forward to seeing you again soon. Thank you.